Great. Chris Robson, CEO and co-founder of Wyvern. Really excited to have you on the Geospatial Index. Part of the reason why is your first Earth observation constellation that we've profiled. There has been a bit of commentary across a few different episodes on the state of the Earth observation subindex. This is in the context of the Geospatial Index, a listing of 350 publicly traded companies around the world. There have been a few comments about how things are going generally in that industry. So yeah, really happy to have someone from the industry on. Let's go.
That sounds great. Well, it's great to meet you. My name is Chris. I'm CEO, co-founder of Wyvern. So the thing that you should know about Wyvern is that we measure chemistry from space. We take high resolution hyperspectral images of Earth and we sell that data to folks across multiple industries: government, defense, forestry, energy, mining, agriculture, finance, insurance, and climate, along with some others that are some other niche industries. But essentially, with hyperspectral imagery, as I mentioned, you can see chemistry from space. And so, what does that mean? It means that instead of seeing a forest, instead of seeing mountains and rivers, you can see the species of tree, or whether or not there's a pine beetle infestation, or if there's water moisture in trees and soil. You can see methane. Not with our current satellites, but with our future satellites, you'll be able to see methane. Hyperspectral is an incredibly fascinating image modality for that reason.
That's amazing. It's interesting you've mentioned methane because that's something I've come across a lot in the sort of spatial finance sphere. I think GHG SAT is one that offers that. It's really interesting to see those plumes. So yeah, I'll keep an eye out for the new capabilities or future capabilities of your constellation. So I guess in my intro comments, I sort of mentioned the Earth observation subindex, so-called, or that as kind of the niche. Is that in fact the niche you see yourselves dominating or seeking to dominate, or is there a more defined niche that you have?
Our niche is definitely high resolution hyperspectral imagery. Yeah. And we don't do analytics either. And as a result, we're very purely a data supplier. That's entirely our niche is high resolution hyperspectral imagery.
Yeah. Okay. So just to keep those who are maybe a bit new to our industry up with us, what does hyperspectral mean?
So what hyperspectral is splitting the light spectrum into multiple contiguous bands across the entire range. So, for example, with a typical optical instrument, you might be taking a red, blue, green picture, and where you're taking it three different images in all three of these bands, and you're combining them together into the images you and I both see. But hyperspectral imagery is where you take the exact same range, but you split it up into tens to hundreds of different colors, and then you stack them on top of each other. By doing this, every single pixel, you get what's called a spectral signature in that pixel, where you've got a stack of all those colors, and that those unique colors tell you something about the chemical composition or the chemical process or the material material properties that are inside of that pixel. So essentially, the way it differentiates is the colors. It's and specifically, multiple contiguous colors across a spectral range where they're right next to each other as opposed to being far apart.
Yeah, well, and you mentioned that some of the benefits of that approach are literally identifying individual chemicals or tree species. So it sounds pretty powerful.
It can be incredibly powerful. It's a very difficult thing to do well. And there are trade-offs, of course. It's not a silver bullet, and I don't believe that any data modality in particular is, but it's a very useful type of image modality that is only really starting to become available commercially.
Just to correct myself briefly, I have had Gabe Domoncello on from Umbra. They do SAR or synthetic aperture radar imagery. I guess I view you, though, doing hyperspectral as being more, I guess, traditional Earth observational or remote sensing. But just to make sure that I'm correctly characterizing, the small survey of the industry that I've done, yeah, you, I guess, I suppose, are the second Earth observation constellation that we're profiling. All right, so just a couple of questions to dig into the business a bit more before we look at actually specifics of what you offer. So then, who is your ideal customer, and how do you ensure you're always working backwards from their needs?
So our ideal customer really falls into, I would say, into two categories. One is on the government and military side. These are purchasers of large volumes of data for either national intelligence or for national science programs. The other ideal customer is from the commercial side. We primarily serve large enterprise users. So folks that already know what to do with the data, they've used hyperspectral from airplane or from drone in the past. They are familiar with satellite imagery. They've already got a use case, and they don't really need to be taught about hyperspectral. They can just grab the data and say, yeah, I know what I want to do with it. Let's get started. And that extends across multiple industry verticals. As I mentioned before, mining, energy, agriculture, forestry, insurance, finance, and so on. We also do serve analytics companies as well, especially those that do have a sense of what to do with hyperspectral data. But I would still characterize the analytics part of our business as being something that is still in its nascent stages. And a lot of analytics businesses do serve a very, very specific and particular use case that often involves multiple types of data, not just hyperspectral.
Okay. Yep. So it sounds like you're used to dealing with highly educated, skilled technical operators in the imagery and analysis space. But what specifically, just addressing the processes you have in place about remaining aware of, keeping up with the needs of those customers? Do you have any sort of structured approach there to make sure that you always have something relevant to offer them?
Yeah. So when we got started, one of the first things we did is we spoke to about over 50 users, customers, subject matter experts, resellers in the industry, not specifically about hyperspectral data, but about what sort of issues they had with Earth observation. And we use that to build our offering. And so today we've got data in space. We're pulling data from the Dragonet satellite constellation. That's with our partner ClydeSpace. We've got a few more satellites coming up in the next year with our partner Loft. Well, that's providing this new data set that we have right now. Well, our first data set, I should say. We're taking that data, we're selling it to customers, and we're getting feedback from them. We're asking them what they're looking for more of. Are they looking for more spectral bands? Is SNR more important? One of the problems we had in the early days is because a lot of users hadn't seen commercial hyperspectral imagery, nobody really knew what the most important thing was in terms of SNR or the number of bands, unless you found a subject matter expert who regularly flew drones and airplanes. They were very particular. They wanted more SNR, and generally the thesis, the opinion was that more than 40 bands in a given spectral range was probably too much.
Yeah.
But
sorry, I have to interject. What does SNR mean?
Oh, signal to noise ratio. So a big, very classic issue with Earth observation satellites. You're so far away, you've got such a small aperture. You need to build a good quality image that gives you a really great radiometric quality. And so you're trying to get as much signal out of that to avoid all the noise that's coming in your imagery. Lots of, it's a very classic problem that EO satellites have.
Yeah. Okay. You mentioned Clyde. Are they a Canadian launch company?
Oh, AAC ClydeSpace. They're a UK satellite company based
Okay.
out of. They're actually based out. The parent company is actually based out of Uppsala, but the satellite company that we work with directly, the subsidiary is based out of Glasgow.
Okay. So where do they launch from? Where have your satellites launched?
Oh, so they're the satellite supplier. They build, they operate.
Okay. They make them for you.
And we launched these satellites with SpaceX.
Okay. Wow. Awesome. All right. It's nice to get a little bit closer to this, really interesting dynamic industry. Okay. So then I guess as a measure of your niche definition, your ideal customer definition, your success in working backwards from the needs. How fast and sticky is growth?
Oh boy, it's hard to say how sticky it is just yet because we've only been offering data commercially for a few months now, but you know we've been growing like crazy. Um, I don't know if I can publicly put a number to it, but well, let's just say that
Crazy is enough of a metric.
we're getting a pretty full on our list of capacity right now.
Yep. Okay. It's good to be running at capacity for sure. Okay, so then let's dig into a few of the specifics of what you have to offer. So then, how can Wyvern help with invasive species management?
Oh, that's a great question. So the great thing about hyperspectral, because you can do things like identify different plant species based off their spectral signature, what you can do is you could look at, let's say you've got a site that needs environmental remediation, a mining site, an old oil, an abandoned oil and gas well, an old industrial site. What there's a lot of things that you can measure, but invasive species in particular is a really big part of it. A lot of these sites end up getting invasive species, and with typical satellite imagery, you don't see the species, you just see how green it is. And so, one of the things I heard a customer of ours say was that in the Permian Basin, they had all these sites that were being environmental remediated, and you check them from satellite, and it'd be like, oh, these are great. They're green. They're growing
Fantastic
great.
biodiversity.
Fantastic biodiversity. And then you go there, and it's all invasive species. And
Right.
all of a sudden, you got to change everything. You got to rip it all out, and you got to replace it with the local species. So hyperspectral allows you to see that without having to send somebody into the field.
Amazing. Yeah. So there's safety implications there, the cost of transport, vehicle hire, logistics, all sorts of savings. Wow. Have you done any characterization actually of the cost savings?
Oh, you know what? I don't know that we have done that characterization yet. I know that we've sold imagery specifically for that, and that
Mm.
the customer wanted this specifically to save on money, and also because they couldn't hire enough people to handle all the work that
Yeah.
they had.
Yeah. 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 Oh, that's amazing. Okay, yeah, I sort of zeroed in on that because I've never really seen the idea of assisting with invasive species management using remote sensing data before. So that's a nice, unique one. All right, then. So, what are some examples of things that can be detected using your Dragonet constellation, but not other constellations, due to its world-leading high spatial resolution?
Oh boy. Well, so it's hard to say yet because other we haven't been able to see any other examples of hyperspectral constellation imagery in the market. Um, I can tell you that what you can see versus say what you would get from other multispectral instruments is you're able to see things like is that real grass or is that fake grass? I
Wow,
will
really?
I will caveat that by saying that I actually don't know for sure if multispectral could see that. There probably is a multispectral satellite out there that does that, but you're able to see a lot of chemical signatures that otherwise you cannot correctly characterize using a multispectral instrument because you can see that level of detail. But things like road materials, building materials, a lot of applications for our current satellite constellation is in vegetation management. Being able to see those species, being able to see if a particular type of stress is going on in a crop. That part is really exciting. I know that one application for our data is being able to optimize the number of soil samples you can take in a given area. Big problem if you're in agriculture. Lots of time and money goes into taking soil samples, so picking the best spots to do them is really important.
Okay, so you can use, there's so many different directions to go in from what you've just said. So, can you characterize using your hyperspectral imagery the makeup of the soil if you've got some sort of a bare earth exposure, um, to as I guess you're saying to target where to put the boreholes?
Well, so you can't see below the surface. Just
Yeah,
to be very clear, and that's
but
something I
also
see
you
in the
need to
market.
not have land cover, right? Or what if there's land?
So what you do is when you're doing these soil samples, you perform them in some sort of grid pattern or there's a few other methods that you use to decide where to put soil, like to where to put the boreholes. But the thing is that If you want to, you could reduce that by 50 to 90% purely by saying, okay, well, this area of the field has been, is generally performing at the same level of health,
Yeah.
and probably belongs in the same zone. Now, also, just to be very clear, I'm not an agronomist,
Yeah.
so I'm probably saying something deviously wrong, and somebody's going to slap me later. But
I understand the theme. Yeah.
you're not characterizing what's below the soil so much as you're saying, okay, if I took 3 boreholes here, they would probably come up with the same results based off the health of the vegetation above it.
Yeah.
And based off of what I can see of the soil properties on the very surface of the soil.
Okay, so it's taking the land cover as a proxy somehow for what's going on in the soil and using that to direct some sampling efforts.
That's right.
You mentioned looking at pavement or surfaces. I've had some involvement in my career in the highway design and just general linear infrastructure maintenance space. So, is it possible to use hyperspectral imagery to somehow detect or assist in a highway maintenance program to look at, when it might be deteriorating to a point where, you might want to look at replacement or more high frequency maintenance?
So, like, technically, yes, there is certainly a application for hyperspectral imagery in road maintenance, especially detecting deterioration. The question really is can you do that effectively from satellite? You should see a very clear change in color, or well, in the spectral signature of a road that has been deteriorated. I mean, you and I already see it with our eyes, right? So it's something that could be done, but it's not something we've explored with a customer yet.
Mm.
I know I've seen scientific papers about it. Yeah.
Okay, so it immediately seems like there might be a market there. That sounds very, maybe hopefully there's some listeners whose ears have pricked up about the potential for highway surface analytics. I guess this is sort of linked to another comment that actually Gabe made about Umbra and the use of SAR to actually detect when a power line is in use. And he said that because like SAR can be used to basically measure distances between the sensor and the object. And the power line could sag in a different way when it's in use compared to when it's not. So I guess it seems like your company is another instance of an Earth observation service or information source that can sort of assist in understanding the dynamics of infrastructure.
It can, yeah. You can detect. Like, the nice thing about hyperspectral is that it's very good at change detection. We often, a lot of our customers are looking for things like right-of-way monitoring. So, for example, being able to detect underground pipeline leaks. That's a really great example of infrastructure monitoring for hyperspectral. You're not necessarily seeing the actual hydrocarbon though. What you're seeing is you're actually seeing its impact on the vegetation around it. Unless it actually seeps up and starts leaking out of the ground. I mean, at that point, it's probably going to be seen by somebody else, unless you're in a remote area. And I mean, that's the thing about a lot of this infrastructure is that some of it is in a very remote area. That's why satellite imagery and hyperspectral in particular lends itself so well to it. So leak detection is a good one. Being able to do analysis on potential interference of vegetation and right-of-ways is another really great example. So, back to that invasive species example, being able to see if it's growing inside of a power line right-of-way, or if there's something that's encroaching on a right-of-way, like maybe a tree is growing really, really quickly and it's about to fall down on the power line. You can see that kind of thing.
Yeah, I mean, I've got a bad habit on this podcast of linking the current guest to other ones. What you're reminding me of actually is Spot It, which is this Oxford, UK-based startup, and the tagline I sort of came up with for them was writing to utility databases from space. So they're kind of like an analytics company that could consume, as a data source, what you guys offer from your hyperspectral constellation. And they actually have some customers in the UK, power line operators. So yeah, I might just send them an email
I'd love
after
to,
this.
yeah,
Actually,
would love to talk to them. I'd love to get them using some of our data.
sure. Okay, happy to hook you up with the CEO. Okay, so why do you promise not to build or sell analytical solutions?
There's a few reasons. The first one is that one, there's hundreds, if not thousands, of applications of hyperspectral data. If you put a hyperspectral image into Envy, for example, you'll see you'll see a ton of different just indices pop out of that. And then with the advent of artificial intelligence, you're going to start seeing a whole bunch of different geospatial AI come out, but they're all going to have very specific applications. We don't really know. First off, we don't really know which one is going to be the best one. But the second point is the second thing that we realized in the early days is that a lot of these don't scale globally, and a lot of them require very intimate knowledge of the region, of the subject being studied. They require local relationships. If you're looking at corn in Alberta, it's probably going to be different than how you grow it in Texas. The season is different. The climate, the seeds might have a different variation based off of what company that a farmer bought them from. But we're also not agronomists, so we're not experts in necessarily an analytics product. So we realized very early on that, okay, well, it's not necessarily something we could scale to the whole world. There are examples of it, don't get me wrong, but for the most part, it's not something we can do. That's not where our expertise is as a team. We've built satellites before, but we haven't built this analytics product using hyperspectral data. It's almost its own separate business. It's a lot of our customers don't like the fact that they have to compete with their suppliers.
Yeah.
But there's also all these folks around the business, around the world, that are using satellite imagery for very bespoke and very unique analytics products in their local region, and we could just serve them incredibly well instead of trying to be all things to all people. I don't think there's a good reason to do it.
Yeah.
I think there could be a good reason if we decided to verticalize around one, and you do see this with other satellite companies. So, for example, GHGSat is a great example. They built a satellite specifically to monitor methane, and that's what they verticalized around. It was a great idea. But then you see folks that are trying to do everything, and they're doing it, but they're not necessarily doing it well. They're not building partnerships. They don't really know what's going on in the ends with the subjects of the analytics. You try to sell to a farmer, you're going to have to, your sales team is going to have a bunch of trucks, at least in Alberta. You have to have local relationships. You have to go out to the farm, and you have to actually, you have to talk to them. There's a lot of good reasons that we don't want to do analytics.
I got a related question. So, if I'm not mistaken, in the past year, John Deere put out a tender for a Earth observation constellation partner. Are you aware of that? I mean, it seems like what you offer as a unique in the market sort of hyperspectral company, a company like John Deere would be particularly interested in you.
Yeah. They definitely would be. At the time of that, I think at the time of the proposal you're referring to, we were still early. But in my ideal vision of the future, you don't even think about the fact that the analytics your tractor is using is coming from a satellite in the sky. We're just capturing data, streaming it directly to somebody who's already built this program. They're doing the analytics, and they're uploading it directly to they're either sending it to an agronomist or uploading some sort of instruction set to a tractor so that you do what you want. But that's definitely something. Like, I would love to partner with John Deere. We would be a very good partner for them because of that reason. We don't do analytics, we just do the data.
Yeah, so naturally there's a so-called precision agriculture sub-index for this geospatial index that I'm maintaining. John Deere's in there, AGCO's in there, Komatsu's in there. So I guess I'm saying there's some American and Japanese, essentially agricultural vehicle manufacturers that supposedly offer some satellite-directed, service or function for their fleet. So have you been making any contact with or inroads into generally this sort of market or submarket?
We definitely have agriculture customers.
Yeah.
we've definitely got agriculture customers. We're still working to define some of the relationships with some of the larger ag firms. But yeah, we've definitely started to make inroads there.
Yeah. Okay. All right. I won't press you too much more. Okay. So then, what, if anything, are your customers saying to you about their AI needs?
Oh, you know what? A lot of our customers don't necessarily talk about their AI needs today. I actually haven't heard that. I haven't heard a customer talk about that. Lots of our customers are talking about what they need us to either improve about the data or what they really like about the data. That's that's really the only thing that they're talking to us about at this moment.
I actually like that because there's so much hype around AI. And here's someone that you said you're having a lot of growth, a lot of success with your customers. And yeah, it's refreshing to hear that, yeah, AI isn't a necessity.
I agree. There's a lot of hype around it, and I think that artificial intelligence will become a transformative technology in the geospatial industry. It's going to take time. It's not something that's going to be done today, and you don't necessarily need it for a lot of things.
Yeah. Again, I love hearing that from a leader in the Earth observation industry. That's really nice.
It's a tool.
Okay.
We use tools for different things.
Yeah, that's right. So I've got one off the cuff question or unscripted one, if you don't mind, before the last one. So I guess I started off with some wry remarks, if you like, about how the general Earth observation industry is going, especially the publicly traded subset of those companies. So I think I put on LinkedIn in the past couple of weeks a screenshot of the 20 companies, publicly traded ones that I'm tracking. And over the past 5 years, there's only 3 of them that are above zero. And there's 2 that are from Japan, and one of them is from Korea. All of the ones in the US have crashed and basically. So, as an industry insider, do you have any comments to make, I guess, about the contrast between the type of growth you're seeing, but the apparent lack of growth, at least in terms of the publicly traded versions of these companies?
I'll tell you what I think. But just to be very candid, I'm by no means an expert in what's going on in these publicly traded companies. I think that a lot of the American EO companies that you see, and I think you're referring largely to the ones that did the SPAC back in 2021.
Yeah. Key comment there. Yeah.
I think that they took it. It was an opportune time for them to raise money, and they went out and they did the SPAC because they were able to raise a lot of money in a market that was incredibly frothy. I don't think there's much more to it than that. If you were to do this in a normal financial environment, I would argue that none of them were really ready for an IPO at that time. They were still growing, but they took advantage of the fact that money was in a lot more supply. There was a bigger supply for dollars at that time. I think one of the reasons why they're not necessarily performing to the public market's expectations is because they're just too early. And you're starting to see improvements as well. You are starting to see these companies slowly inch up towards profitability, and they'll get there, I think. But yeah, as far as I'm concerned, it's just a matter of being too early more than anything, and the market realizing.
Market also maybe got ahead of itself. Believe.
Yeah, they're resetting their expectations for that.
Yeah. Okay. Again,
expectations were far too high for those companies when they came out.
Yeah.
And that's just that's a matter of the market. I think that I don't have a good insight on necessarily all of the EO companies, but if I had to pick out a main factor, it's that I think some of them try to do too much too quickly. Like the thing about Earth observation is that it's incredibly complicated from a scientific perspective as well as an engineering perspective, and so you've got to grow at the right pace. If you try to grow too fast, you end up putting a bunch of satellites in space that people aren't necessarily buying the data from because they're not necessarily ready to roll it out on a large scale yet. You got to go through a trial, you got to improve data quality, you've got to get it to the point where it's useful, and it's hard to design that for the first satellite the first time. Anyway, I hope that helps out a bit.
Right. And so I guess your observation is that they're kind of still building the plane as they're taking off. And yeah,
Yeah,
that's not a good time to be demonstrating the kind of financial metrics that a lot of investors might be after.
100%. Yeah, like
Okay.
there's no other way to say it than the way that you just put it.
Yeah. Yeah. No, I love the cold, frank observations. Yeah, from an industry insider. That's really appreciated. I guess I've got another question that I'd like to try to lever in before the last scripted one. So could you, I guess, characterize the next, couple of years or something about the release pipeline or the roadmap? What's next that you're uh, planning to release in terms of the capabilities of your constellation that listeners might want to keep an eye out for?
Well, we're definitely going to be launching more Dragonet satellites. We're going to be flying like our next generation is going to be really interesting. It's going to I think the resolution of those satellites will surprise people when they come out. I can't comment on the resolution now, but
What is it
it'll be
currently?
sorry. Right
What is
now
it?
it's 5.
5 minutes. Okay.
The next generation though will our intention is for it to include shortwave infrared, as well as visible near infrared. Right now we've just got visible near infrared. Um, that'll open up a lot of applications that involve mineralogy, defense, mining, energy, and methane detection.
Wow. Okay. So, exploration companies then will have more of an interest in what you have to offer.
100%. That's going to be really exciting. And I think in the next, like our biggest, like the way that we, as I mentioned at the beginning, the way that we position ourselves in the market, we're a data only supplier. We do the highest resolution hyperspectral. So you'll see our resolution climb up in the next 5 to 10 years. And as I mentioned, it'll surprise people, I think, when what we're able to get to.
Right. Yeah. Okay. Really exciting niche that you're in. Okay. So then on to the last one finally. How are you fostering growth of the next generation?
What do you mean by that? The next
So,
generation of people, of
yeah,
satellites, of
maybe I should be more specific. Actually, that's sort of a development of the sort of standard last question that I've kind of gone with. I'll give you more context. So in the UK, it's possible to do a geospatial apprenticeship. So what I guess I'm kind of trying to get to there is, if you were going to have an apprentice at Wyvern, what would you be looking for in the hiring process?
that's a really good question.
And then that leads on to you having this apprentice. You are then fostering growth of the next generation, and essentially how are you propelling the industry in terms of people?
I mean, first and foremost, when we hire at Wyvern, we largely look at people that align with our own internal values. But that aside, if you're so first off, we're a Canadian, we're Canadian, but we're Albertan. There's no space industry here really, except for us and a few other folks that are very nascent. If you wanted to work in space in Alberta 10 years ago, you'd have to go and move somewhere else, and you couldn't move to the United States. Um, as a result, that's created a culture of being scrappy. We're pretty scrappy. Um, I tend to look for that when I look at people. People that are scrappy tend to be people that are so engaged in the problem that they're solving that they'll think about things. They'll. I think one of the best interviews, for example, I ever had is I sat down and the person said, "All right, this is exactly what I think you should do because these are all the problems with your company."
I love it.
And that was one of the best things because that means that they were so incredibly excited about working here that they were like, "Oh, I've already got all these things,
This is my
I
interview.
want to, you know."
Yeah,
That's one thing.
yeah,
Another thing is somebody that's willing to take the risk and jump into this sort of environment. Being a startup is, we call it riding the dragon
yeah.
internally because it's like a roller coaster. It's like you're riding a giant friggin' beast, and it has its very sharp ups and downs sometimes. And being able to maintain that level of wide-eyed, bushy-tailed excitement and interest in what we're doing and the mission and vision, and combine that with being able to survive those roller coaster moments. That's part of what makes somebody scrappy, in my opinion. That's the kind of thing that we look for.
Yeah. Okay. So then the logical conclusion there is that you literally are fostering the growth of the next generation in terms of an Earth observation industry in Alberta.
Oh, hold on. Space industry in Alberta. We do have a lot of geospatial people here, though.
Okay.
Alberta is probably one of the few places in the world that
you would have a
really
huge concentration.
how many geospatial people are.
Yeah, absolutely, because of the oil and gas industry. But in terms of Earth observation specifically, could you say that? Yeah,
that's accurate, I think.
Yeah, great. Well, I think that's good a point as any to end on, unless you've got any more observations you'd like to share or ways for people to reach out.
I don't like putting my phone number or email in
Sure.
public anymore because I keep getting calls from people trying to sell me. I think the most interesting thing was trying to sell me trophy cases. But anyways, folks want to reach out on LinkedIn. I'm always happy to hear from new people. But thanks, I really appreciate this conversation. It was great to sit here and talk about Wyvern and geospatial and Earth observation.
Yeah, me too. I hope it's not the last one. And yeah, if you have anyone to refer me to next, please, send them my email. Chris.
Sure.
Yeah. So yeah, Chris Robson. Please put that name in LinkedIn, and yeah, people will find their way to you.
Thank you, Will. It was good to meet you. It was good to talk, and let's make sure we stay connected.